Hello everyone, I hope you're doing good this week. You'll notice Beaker's not with us today because, well, he's still acting a little strange. Okay, what is going on? I'm not Beaker. Okay, while I try and figure out what's going on here, please enjoy this lesson. Okay, we're going to start our final look at some friction problems. And a couple important notes we want to make before we get started. Number one, we have mu k, which is the coefficient of kinetic friction. That means the coefficient of friction when the object is moving. Mu s is the coefficient of static friction. That means the coefficient of friction when an object is sitting still. Remember, it always takes greater force to get something moving than it does to keep it moving, so UK is always less than US. Always. The formula for friction force is friction force equals mu times normal force, keeping in mind that we have to choose the correct mu, either mu K or mu S. So friction force equals mu times normal force. The normal force is the same as weight. It's equivalent to the absolute value of the weight. Weight is always negative because it's going down. Normal force is always positive, but we work it the same way. It's mass times gravity. Now we start thinking about the net force. The typical formula for net force is net force equals applied force minus friction force. But we can word problems in such a way that it's actually not the applied force minus the friction force. It can be the applied force plus the friction force. The best thing for you to do is to always draw a picture. If the applied force is going this way and the friction force is going this way, which is normal, that is literally the typical example, then it would be this applied force minus friction force. But there can be examples. I believe number 8 on the sample problems we did last week, we had the motion was going this way, and that made the friction force going to the right, but the applied force was also going to the right, and so that ends up giving us a net force in that case of the friction force plus the applied force. So you always have to, basically, it's best to just draw a picture, and if you get confused, just stop for a minute, look at it, and just make sure that your forces are going in the right direction before you decide if it's addition or subtraction. And don't forget that for all motion, force equals mass times acceleration. We'll take a quick look at a couple of examples. For example 1, we have a coefficient of kinetic friction of 0.3, a coefficient of static friction of 0.5, and we want to know what horizontal pull or applied force is required to start a 250 Newton block moving. Note this right here. This is a 250, they're giving you the normal force. That's automatically. So notice this problem is not giving you mass, it's giving you the normal force, so we can just use that directly. So to solve this problem, we just simply used friction force equals mu times normal force. Now pause for just a moment and think for a second. Which mu am I going to use? Am I going to use mu k or am I going to use mu s? I'll read over the problem one more time. Which P is required to start a block moving? That means the block is sitting still. It's stationary, and if it's stationary, we use the static friction. So I do friction force equals mu S. That's going to be 0.5 times the normal force, which is already given to us, of 250 newtons. And that gives me a friction force of 125 newtons. Example number 2. Same scenario, same thing, but the same values, but the question this time is what force applied, what pull or applied force is required to keep the block moving. It is already moving at a constant rate. So again, all we're trying to do is find the horizontal force. Well, if an object is moving at a constant rate, that's the applied force, then all I have to do is balance it with the friction force. Those two would have to be equal to each other. And since they have to be equal, I can just find the friction force, which equals mu times the normal force. Mu in this case, I'm going to use mu k because the object is moving. So 0.3 times 250 gives me 75 newtons. That's the amount of force required to keep an object moving at a constant rate. Note, if it's constant rate, applied force and friction force are in balance. They have to be in balance. Now let's take a look at example number 3. The block is moving at a constant rate, but I want it to accelerate at 0.5 meters per second squared. Well, that's going to come back to net force equals mass times acceleration, where that is 0.5 meters a second squared. But you'll notice, to solve that, I have to have mass. So we're going to have to kind of work in reverse here. And we'll go with the normal force, which is given here, equals mass times g. So I'm going to find the normal force, 250 newtons, equals the mass times 9.8. And that gives me a mass of 25.5 kilograms. That mass can now go into this formula. So I have the net force equals mass times acceleration. The mass is 25.5 kilograms. The acceleration is 0.5 meters a second squared. And I end up getting a net force of 12.75 newtons. Now, we're going to pause here for just a second because we want to make sure we're clear. This is the net force required to make the object accelerate. But we, at the same time, already have a friction force, don't we? Well, the friction force we solved just a few minutes ago when we looked at example number 2. And that friction force was 75 newtons. 75 newtons. So I'm going to give us a clean page here real quick. So we came up with a net force of 12.75. We have a friction force of 75 newtons. Both of these are newtons. So I need to find the applied force. Well, in this case, the object is moving this way. That's my applied force. And friction is moving this way. That's my friction force. So the net force is equal to the applied force minus the friction force. So the applied force is going to equal to the net force plus the friction force. Friction force, F, there we go. So I put in my net force of 12.75, my friction force of 75, that's going to give me my applied force, and my applied force is 87.75 newtons. So if I have an object moving at a constant rate and I want it to accelerate at 0.5 meters a second squared, I would have to go from 75 newtons to 87.5 newtons. I hope you found that informative. As for Beaker, Misty's going to have a little chat with him, and I think he'll be better by the next time we talk. Quick reminder, this week will be the last week of instruction before spring break. During spring break, there won't be any lessons posted or any more activities for you. If you are behind during spring break, I will still be checking my email and checking Remind. I don't think I'll be sending out anything. But if you need help or you have a question during spring break, you can always get back with me. As always, be smart, be safe.